Hello everyone, welcome to this new video. I'm adding this to the tolerance stack up analysis for more practice. This is slightly complex example. I will be guiding over here. You can do the complete analysis and can send it me on my mail ID. I will be providing you this full solution. So let us start now. This is the assembly what we are going to do, the tolerance stack up analysis for this. The base plate is over here. Two L sleeve plates are welded. This is welding overdone for both plates, and some components are over there. So this is not about the functionality of this assembly and all. I will be explaining how to do tolerance stack up analysis for this assembly. Moving ahead to the two-dimensional drawing over here, I have added all the dimensions, required dimensions from this individual drawings. So this assembly has many components and there will be some individual drawings for these components. I have added the dimensions, required dimensions in loop diagram in this assembly. We will prepare the loop diagram and we will try to solve this thing. So if you see, this plate is welded over here and this dimension will be given in assembly drawing. So these plates are welded and we are interested in finding out this gap. These two components should not touch at any cost. So we need to define this min and max, and minimum should not be interfering. So that is our check. And that's why we are doing tolerance stack up analysis. This is a linear tolerance stack up analysis. So we already know the rules of making a loop diagram. That is, we can start from one end of the loop and we have to reach till other end of the gap, that loop. So that's how the loop should be closed one. To jump from one component to other component, there must be a surface to surface contact or the axis is aligned. So these are certain rules. Just to revise, let us start making loop diagram over here for this assembly. So this gap we are interested in finding out, I can start it from here. You can see the dimension is given over here, right? So first of all, for any of these, we have to convert these limit dimensioning into equal bilateral tolerances, right? You know how to convert. So upper limit plus lower limit divided by 2, that will be the mean dimension. Upper limit minus lower limit divided by 2 will be the symmetric tolerances over there. So we have to convert that. I'm not going to do that. So first do that and then start preparing loop diagram. I'm starting from there, so I will go from here to here. So that will be A for me, right? I reach till this point because this dimension is given on drawing. If another dimension is given, I have to prepare loop based on the dimensioning scheme on the drawing. So before preparing loop, we have to understand that. Now I have reached here. I can see the thickness of this green plate is given. I will go from there to there. That will be B for me, right? So using that, I have reached to this surface now. Now I can use this dimension to reach here. So I will be using that to reach the back surface of this L plate. So that will be C for me. So A, B, C is there now, right? Do I need to use this thickness? No, I will not be using this, right? Why to use that as this dimension directly given from there to there? So I will be moving from here. So one surface of this back surface of L plate to the another surface of L plate only. So that will be D for me. Okay, A, B, C, D I have, right? So that's done now. Now I need to go to this surface. Why? Because this thickness and this thickness is given. So this thickness is given over here. Now I will utilize this thickness and will reach over there. So A, B, C. Now using the thickness of L plate, I have reached the other surface of the L plate. Now using this thickness, I will move over here. So A, B, C, D, E, and this is F for me. Now, as I am on this surface, the dimension 7.3 plus or minus 0.50 is given. So I will use that and will go back to this. See, we have now closed the loop. So in this way we can prepare the loop. As these plates are welded, this will be fixed over there, and the how apart they are, that dimension should be given on drawing, and we are using that dimension and we are preparing this loop. One more confusion in the scenario of tolerance stack up analysis: which direction to take positive. There is no such fixed rule that left should be positive, right should be positive. We have already seen that the dimension increases, increasing the gap. The dimension that increases, if the gap is increasing, that's a positive impact. So that dimension should be positive. And the dimension that reduces and gap increases, that should be always negative, right? So here, if I increase the dimension A, the gap will reduce, right? So in that way, A should be negative. So for me, this direction becomes negative and this direction will become positive. Now what happen if someone start the loop dimensions from that direction, right? So let us do that as well. So I will just erase this all. Just going one by one. Just bear with me. Okay. Now we can prepare the loop from other direction as well, right? I'm interested in finding out this dimension, right? Now I have started from this side. So I reached till this surface because this dimension was there. Then utilizing the thickness, this is A for me. Now this is B for me. Utilizing this is thickness, I will go to the back surface of this, that's B. Utilizing the L plate thickness C, that's C for me. I will reach its back place. How I am jumping one component to other? Because it's in contact surface to surface. In this case, there is no such axis, so we are not doing that. So I have reached to this surface. Now I will go from here to here. So A, B, C, D for me. Then this dimension is there. E, this is F, and then using this I reached here, that's G for me. Same number of dimensions are here, either I started from here or that side. G, A to G is the loop for me. Now what happens in this case? In this case, if I examine, this direction will be negative and this direction will be positive. Okay, so we have to be always careful. It's not like which direction is positive. We have to know this rule. Now moving ahead, you can prepare this table, right? And let me know the values. You can put the plus positive dimensions, negative dimension, and tolerances, and you can get how much it is getting. One more check. Usually these days we are using SolidWorks or any other CAD softwares, right? So in that case, you can measure the mean gap always. So if you see here, if I measure this mean gap in a CAD, right? So see 6.1 I am getting. So my mean in my tolerance stack up table should be always this. I should reach to this mean only. If this value I'm getting something else is into my tolerance stack up analysis, that means it's wrong. Something is wrong in my tolerance stack up analysis. So that can be a check. In a CAD, this is the mean dimension we are getting. So that's the thing. In that way you can do it. Prepare the loop diagram, prepare the stack up table, send it to me on my mail ID. I will respond it to it if it is correct, right or wrong, and I will provide full solution if you want. So this is one example. Now moving to the next example, it's the same. It's almost similar to this, but it's a bolted connection now. Instead of welding, it is bolting. See, same example now. The the welding is replaced by bolting. So here bolted connection is there. Now we need to prepare loop diagram for this. I have again collected the dimensions, required dimensions from the drawings over here, and we want to prepare loop diagram for this. Now let us start preparing loop diagram. The change is only one thing, that bolted connection, and that maybe some dimensioning style. So now I have also put every dimension over here. I am interested in counting this gap over here, min and maximum. So let us start preparing loop diagram from here. So if you see, this dimension is given directly over there. I will go from here to here directly to the other surface, other side surface of this green plate. So that's A for me, right? So that is A. Now this, if you see, 8.6 is given over here. In this scenario, as I have already reached to this surface of the green plate, I need not to consider the thickness of the plate. This will not be considered into tolerance stack up analysis. Now reach this place, 8.6 is given. I will use that, will reach from there to there. That's C for me. Sorry, that is B for me. A and B. Now from the back surface, if you see, 12.1 is given. That is the center location of this part, L bracket hole. So there is a clearance hole over there, and the center of that hole is located from this surface by this dimension. So I can use that because I'm on the back surface. I will directly go from there to the center of that surface. So that's C for me. Okay, so preparing the loop from there to there, that's C for me. Now I'm on the center. Considering the axis of the L bracket and the base plate holes are aligned, I'm considering this over here, that the axis of this and axis of the plate are aligned. I'm considering that and making this loop diagram. So I reach till there, and as axes are aligned, I can jump from this plate to this base plate, right? So I am jumping to the axis of this base plate, and this dimension is given over here. So from there, I can reach to the other center location of this hole, that is A, B, C, D. Maybe D, or we might need to change this. Why? Because there is a play also. If you see, the clearance holes are always larger than the bolt diameter. So we need to consider those as well, because there might be chances of movement due to that larger clearance hole, and that is going to impact this gap. So we need to consider that. How to do that? See, clearance hole, suppose the M4 fastener is going to be there. So considering the diameter of the bolt M4 as a 4 mm, you can exactly go to the dimensions and check the M4 dimensions and take the measure diameter. That is also okay. I'm taking 4 mm for now. So that is there. M4 fastener size is 4 mm, bolt diameter I have taken, and clearance hole dimension is given 6.3 plus or minus 0.3. What is worst case dimension of the clearance hole? That is 6.6 mm, right? 6.6 mm. What is the bolt diameter? Bolt diameter is 4 mm. So 6.6 minus 4, that is equal to 2.6. That's the diametrical movement available for L bracket as well as base plate. So I need to create this into radial to make it as a tolerance. So I will divide it by 2. So plus or minus 1.3 is the dimension I need to consider. This is movement available for this and this as well. So A, B, C. Then considering the movement of L bracket over here as a D, considering the movement of base plate over here as a E, A, B, C, D and E. So this becomes F for me, this loop. Now I am on this axis of the base plate. I need to jump on the L bracket, so I can jump it over there, but meanwhile I have to consider over this side as well. So A, B, C, D, E, F, G and H for the same variation of 1.3 plus or minus 1.3. So I am now reached on the axis of L bracket over here. I can go from there to this back surface. This dimension is available over there. So A, B, C, D, E, F, G, H, this will be I, then this thickness J, then this thickness K, then overall length is given over there L. So A, B, C, D, E, F, G, H to L. This is the loop dimensions over here. Now we can prepare the loop diagram over. We can prepare the stack up table as we have completed the loop diagram, put all these values over here, and then you will get the answer. Now in this case, which direction is going to be positive, which direction is going to be negative, right? So that will be also a question. Same, the dimension increases, reducing the gap should be negative. So A increases, reducing the gap, so that will be negative. That means this direction becomes negative for me, this direction becomes positive for me. You can also start preparing loop from the other side. Answer is going to be same. So that is one way of doing this tolerance stack up analysis. This is one way of doing tolerance stack up analysis. Now when you will be writing this over here, so in place of D and E, what you are going to put in the dimensions. For D and E, just put nothing over there, put plus or minus 1.3 plus or minus 1.3 over here in the tolerance analysis. Similarly, it will be for other side as well. So you need not to put these dimensions, directly put these dimensions over here, these tolerances over here as a tolerance. Okay, so in this way you can complete the loop diagram and complete the stack up table and let me know the answer. Instead of calculating plus or minus 1.3, you can directly consider those diameters into tolerance stack up analysis. How to do that? So in case of doing it, to reach the from the L bracket we reach till there, right? From there to the center of the hole we can reach, right? That is available. So that dimension is available. From the center of the hole, considering the diameter of clearance hole on the L bracket, I can reach to this edge over here, right? So that will be another dimension in loop. Now I know this diameter of means this bolt, that will be a. So considering this into tolerance stack up analysis, this into tolerance stack up analysis, then diameter of the bolt into tolerance stack up analysis, then this surface is in contact with the base plate, considering the 1 scenario for the gap. So I'm here, now I can reach to the center of this hole. So A, B, suppose how much it is increasing, suppose this is A, then this is B, C and D. Then in this way I will be reaching on the center of this base plate, and then the other loops will be similar. So instead of considering the another method, this way is also fine. We will get similar results. So anyway you can choose and prepare the tolerance stack up table and let me know. Now in this case as well, if you go and measure the mean gaps, remember to measure the mean gaps, the dimensions should be all the dimensions, all the dimension of these parts, whatever we have taken, that should be at its mean. Suppose in your CAD, this dimension over here, the dimension is like 10 plus side 0 minus side 1, something like this, just random. So this is not at mean. So this dimension you will get in your CAD is not correct one. If all the dimensions in your CAD model are at mean, you will get this dimension same as what we got in our tolerance stack up analysis. It should be the same. If it is not same, then we are doing some mistake over there. So I hope this video is clear to you. Prepare the loop diagram for these examples and let me know on my mail. I will be back to you. I will provide the solutions. Thank you so much. See you in next video. Enjoy.